Hey there, Bill Witte back with more pre-algebra. You distance learning students, I got some good news for you. We only have one more test left, don't we? Unless I have to get my mean face out. If you have more than one test left, we've got a problem. I need to remind you a couple things. You know what? Number one, the average grade on these tests at the assessment center is somewhere between an A and a B. But the average grade for this class is an F. You know why? Because some people don't get around to taking their tests. And if you don't get around to doing it, it's a 0. Okay? That's number one. Number two, I need to tell you that there's another class waiting for you after you finish this class. I shouldn't say waiting because they're not going to wait. So if you don't finish this on time, I can't extend it. Okay? So you need to stay on schedule. If you have more than one test to go, then you need to get in gear and get those other tests caught up, okay? Remember, if you need help, you can always go to the home page at www.montgomerycollege.edu/pre-algebra. Okay? Let's see what we have today. Oh, the rectangular coordinate system. This is pretty cool, okay, and useful. You're going to love it. Okay, but you know what? Before we do that, we used some we did some useful stuff last time too. Let's take a look, okay, so that you remember. We covered last time everything about percent.
No way.
Remember what percent means? Fraction out of 100. And you know how they got that sign for percent? They actually
allow me to demonstrate.
Took the number 100 and made a fraction out of it.
It is a lie.
Truly, they did. So that's what percent means, fraction out of 100.
That's the fact, Jack!
Percent. Fraction out of cent, meaning century, 100. Okay? Now, what did we cover about percents?
But now you know the rest of the story.
We covered various conversions. Writing a decimal, for instance, as a percent. Let's do a couple of those. This decimal, of course, percent means fraction out of 100, so we got to get this baby out of 100. So when we have a decimal, we're going to look for not the 10th digit, but the 100th digit and make it a fraction out of 100. Okay, let's just say it. That's 45 100ths.
Oh.
Remember, that's where we're going to put the decimal, 2 places over. We'll have 45 100ths. Of course, that's it as a fraction. I need to write it as a percent. Remember what percent means? Fraction out of 100.
Oh, gnarly!
So once you have that 100, you're rocking and rolling. How about this one? Where's that 100th digit?
Oh.
There she blows. So move your decimal over to that, 2 places, make it a fraction, and now a fraction out of 100, that's what percent means.
Shazam!
And we've got a percentage.
Woohoo!
There she blows. How about this bad boy? Ooh, that could be hard. Fraction out of 100. Move the decimal over to next to the 100ths. Make it a fraction out of 100. Of course, we can't have a decimal in a fraction, so we'll have to...
Hey, this is great!
Write it as a percent. You love it. Now we went backwards. Well, we went to a percent, from a percent to a decimal. Basically doing the same thing backwards. Remember that percent means out of 100. So we basically divided by 100. Okay, when we divide by 100, do you remember what we do? Well, the original decimal place is there. When we divide by 100, we move it back 2 places. There's the 2 places. And 53% as a decimal is 0.53. This will work all the time. Now it's a decimal. How about this one? We want to write it as a decimal. Right now it's a percent. If we want to take that percent sign away, it means out of 100, or divide by 100. So if we divide by 100, we move the decimal place over 2 places. Where is it now? over 2 places. Oh, we had to add a place because we didn't have 2 places to move over. And that's where it ends up, and we've got ourselves a decimal answer. Now it's a decimal.
And another thing.
We also did writing a percent as a fraction. This is a little bit easier, I think. Take this percent. Remember what percent means. Per 100. 40 per 100. Now you've got it as a fraction. Oh, but we always have to reduce any fraction if we can. So we'll reduce this one, dividing both top and bottom by 20. And we got ourselves a fraction.
Cool.
So 40% really is 2/5 downtown on Friday nights. 3.7% as a fraction. Use 100 as the denominator now. Now, ooh, we got another problem. We can't have a decimal in a fraction, so what are we going to have to do?
Houston, we have a problem.
That's all right. We can get rid of that decimal as long as we do the same thing to the top and to the bottom. I'll multiply both by 10. In other words, move the decimal place over 1 spot. For both. And I have myself a fraction, 37 1/1000ths.
You are correct, sir.
Okay.
Wait a minute.
And we go, oh, remember about 100%. It's a very special percentage. Remember that percent means per 100. So 100 per 100, using 100 as the denominator. What is that known downtown as?
Is that your final answer?
No, we could reduce it. And 100 100ths is really 1 over 1, or 1. 100% is 1.
That's the fact, Jack.
That's very important for you to know. That's worthy of memorizing, in fact. 1 is the same as...
And you're going to do it because I said so.
1 is the same as 100%. Please memorize that. You know why I want you to memorize that?
You are correct, sir.
1.00, that's 1, is the same as 100%. Where's the decimal place for 100%, by the way? Oh, yeah, there it goes. Okay. Well, you know why I want you to memorize this? Because people that convert from percentages to decimals, they know they have to move the decimal place over 2 places. They always know they have to do it. But depending on which way they go, they don't know whether they want to go to the left or to the right, and they screw it up. Here's the way I remember. I write down 1.00 is the same as 100.0, if you would, 100%. One's a decimal, one's a percent. And if I need to go to the percent, I can see that I moved to the right. And if I need to make it a decimal, I can see from what I've written that I need to move to the left, okay? I know I had to do 2 places. Nobody forgets that, okay? So that's worthy of knowing. 1.00 is the same as 100%, okay?
Oh, let's get ready to rumble.
What about writing a fraction as a percent? Well, that's not so bad.
Let's play. Here we go.
Basically, a fraction is the top divided by the bottom. So let's take that and multiply by your old buddy 1, but not 1 as his plain old 1. 1 as...
That's the fact, Jack.
Remember I told you to memorize that. 1 as 100%. So 9/20ths times 100%, which is what 1 is. So this baby's going to turn into a percentage. Oh, but let's reduce. Of course, 100% is the same as 100% over 1. Now reduce, crossing out the 20 and the 100. Let's see, I'll get a 1 and a 5, and you got yourself a percentage. 9 times 5, 45%. So this multiplying by 1, or thinking of 1 as 100%, is going to help you in many ways.
Survey.
Let's try this one. No, we're not multiplying by 1, which we could do. We're going to multiply it in its other form.
You look marvelous.
100%. Okay? We can reduce. 5 goes into 5 once. 5 goes into 100. 20 times, and you got yourself...
Oh, yes.
an answer. You got yourself a percent, I should say. Let's do one more.
Bring it on.
Okay, how about this bad boy as a percent? Well, remember that we can change 1½ to 3/2. It has to be a fraction. 1 times 2 plus 1. Okay, not a problem. We make it an improper fraction and multiply by 100%. Reduce. Always reduce if you can. We got ourselves, what's the answer here? 3 times 50. Yeah, that's a percentage, okay? So in summary, our conversions, to go from a percent to a decimal, basically we're going to drop the percentage sign and divide by 100. In other words, move the decimal point 2 digits to the left. To go from decimal to percent, we're going to do just the opposite, okay? We're going to move to the hundredths digit, or 2 to the right, okay? And then, of course, don't forget, you want it to be a percent, so attach the percentage sign. To go from a percent to a fraction, we're going to write the number part over 100 and reduce if needed, because that's what percent means, fraction out of 100. And backwards of that, fraction to percent, we're going to multiply the fraction by 100%, known downtown as 1, but in this case as 100%, and reduce if we need to, okay?
Mayday! Mayday! Come in, Star Command. Send reinforcements.
Oh, when we used a lot of percent questions, they came with words that we might have had trouble with. And I had a kind of a dictionary, you may remember, that would help us with those problems. Okay? And it came in 3 groups. The words what or how much basically would always interpret to
Never know what you're going to get.
a variable, which of course could be, you can use y or a. Most people use x, but it can be any letter. Was, is, would be, convert to, always convert to equals, okay? And the words of, on, are going to interpret to, for all of math just about, multiplication, okay?
Allow me to demonstrate.
Let's do one. What is 6% of 4550? Well, let's do our conversions. What? That's your letter, that's x, that's your variable. Is converts to, always does, you love always in word problems. 6%, well 6% is already in math language. Of, your old buddy, comes to multiplication. And 4550 is, again, already in math language. Okay? Now all you have to do is compute or solve the equation. You've converted it. Okay? 6% as a decimal, that way we can multiply it. Okay? And then just do your multiplication. We got ourselves an answer.
Hey, this is great, man.
Not so bad. Use those conversions.
Do that again.
Okay, how about this one? What percentage on $70 would be $10.50? You want to know what kind of a discount you got. Here again, what converts to the variable? Well, percentage is already in math language, isn't it? On, don't forget what on is. Like of, it's multiplication. 70, already in math language. Would be converts to equals. And the last part, 1050, once again, already in math language. Okay, now we're just going to solve this equation. The hard part to me is getting the equation. We're going to solve it. Got to get rid of that 70, get x by itself. Okay, do it to both sides, Buford. Crossing out, doing the division. We get x% over here, and on the other side, doing the division, I get 15/100ths. Well, let's think about that. What percent is 15/100ths?
Wait a minute.
What does percent mean? Percent means fraction out of 100. So there's your answer. What fraction out of 100 is 15 out of 100? It's like who's buried in Grant's tomb.
Baby, you're the greatest.
You got it.
Thank you, sir. May I have another?
One more for this review, okay? here, 312 is 75% of what number? That's a little bit different, but we can still use the same interpretations, can't we? 312 is already in math language. Is equals 75% already in math language of, you're getting good at this now, aren't you? Of is times. What? One word at a time. What is what? What is what? It's a variable. I probably shouldn't have used x. Remember, you can use any letter because I don't want to mix it up with the times. Okay, now I got to solve for x. Get x alone. Who's keeping it from being alone? The 75%. Probably easier to treat him as a decimal. And now let's get rid of him. He's multiplying, so we'll divide. Both sides, Buford. Dividing and canceling. In this case, x is 416. Worked out real nice.
Excellent.
Okay. Okay, what do we got new for today? That's your review. Remember what I told you we're going to look at? The rectangular coordinate system. This is so cool. You're going to love this. Okay? Well, let's start with the basics. What the heck is the rectangular coordinate system? Well, here it is. Let me give it a little piece at a time. It starts with a number line, okay? Now that number line, we'll say starts at 0. I'm going to put 0 in the middle there, but it doesn't really matter where I put it, okay? Now that horizontal line is called the x-axis, and the plus x goes in the right direction. There's 1, 2, 3, etc. And it also includes the negatives. Don't forget where 0 is. So the negatives will be in the other direction. And there they are. Okay, there's all the x's. Okay, now this is a rectangular coordinate system, not just a linear coordinate system, not just one line. So we're going to go in the other direction as well. Okay, now this axis is not the x-axis, this is the y-axis. Still starts at 0, same place. See where they cross at 0? Now y gets bigger in the positive direction going up. There's plus y. That makes sense. Going up is bigger. There's your positive numbers. And it gets smaller. Still starts at 0. Going down. There's the negative y's. See? The negative numbers going down. Okay? Now you can see why this is a rectangular coordinate system. It is a giant rectangle. Actually, a rectangle of infinite size, but it is a rectangle. Okay? Now, what we're going to use this to do is draw pictures of points or ordered pairs. For instance, the point 4, 5. 4 for x and 5 for y. What we're going to do is start at 0.
It's always best to start at the beginning.
We call that the origin. That's pretty easy to find because that's where the two axes, whatever they are, cross. Okay, there's the origin. And we're going to, two numbers are going to make up 1 point. Okay, let's see. We have to do the 4, and that's the x. So we go over 4. Okay, don't put a dot yet because we haven't done the 5. Now from that position, we're going to do a 5 for y, which means positive 5. Go up 5, and where we ended up, that is the point 4, 5. That's how you plot a point. Note, please, that two numbers make 1 point. Okay, I don't want to see 2 points. Two numbers making 1 position, if you would. Okay? Now, these points are also known downtown on Friday nights as ordered pairs, because order counts. For instance, if we plot 3, 6, remember how to do that? Start at the origin. Okay? Do the x part first. Now, I always remember the x part comes first because they go in alphabetical order. The x part, 3, and then from there go up 6. And there's the point 3, 6. Okay? Now, order counts, I told you. So 3, 6 is going to be different from 6, 3. In 6, 3, we're going to go over 6 and up 3. It's a totally different position. So get used to the fact that these are called ordered pairs because order really does matter. You can't just flip them around. Okay? You get something totally different when you flip them around. Okay? Now, what else can happen with drawing these points? Well, how about this one? Plot 5, 0. It's a little confusing. We do the same thing, though.
It's always best to start at the beginning.
We are going to start at the origin. We're going to do 5 for x, go over 5, and up 0. What do you mean up 0? Up none. Oh, don't go up any. There's your point. There's the point, 5, 0. It can happen. Okay? I'll give you a couple other weird ones. 0, 2. Now, in this case, we're going to do the x first. Remember, the order counts. Go over none.
To start at the beginning.
Oh, yeah, I forgot. You got to start there. Okay, go over none. I didn't do anything. And up 2. There's your boy. Okay, he's not so bad, is it?
Now what am I gonna do?
Well, negatives can come into play here. Let's see. We're going to go back to. Notice we started at the origin. By the way, the origin is the point 0, 0, isn't it? Okay. We started at 0, 0. We're going to do our x first. We're going to go back to, because that's the negative for x, and we have to do a positive 4 for y. Oh. So that's where negative 2, 4 would be. Okay. This isn't that hard now that you get the idea of negatives. We're going to start at the origin.
It's always best to start at the beginning.
The point 0, 0. Go back 5. And for a negative y, we have to go down. And down 3. So negative 5, negative 3 is right there. Okay, this isn't so hard. We're drawing pictures of ordered pairs. How about one more?
Oh, right, guys.
Let's get the hardest possible thing. Let's see, we're going to go back 4.
And all you do is follow the yellow brick road.
Oh, back 4. And up none. This is easy. My mother could do this. Okay? Now, you know what?
Who cares?
That's what I said. What do these things have to do with anything, these ordered pairs? Well, you know what? They could be solutions to a two-variable equation. A solution is something that works. Okay? For instance, x plus 2y equals 11. Some pairs will fit, and some won't. What do you mean fit and don't fit? Let's look at the point 1, 5. Now, 1 is the x and 5 is the y. What if we put that in? Does it fit? Put a 1 in for x and a 5 in for y. 1 plus 2 times 5. Does that equal 11? 1 plus 10 equals, ooh, it does. So that one, quote, fits in to this equation, okay? That's not the only one that fits in, though. How about this one? 5, 3. Let's put, remember, it ordered counts, so the 5 only goes in for the x, and the 3 goes in for the y. Does this one fit? 5 plus 2 times 3, 5 plus 6, son of a gun, it does equal 11. So that one fits too. Oh, there's a whole bunch that fit. Not all of them fit, though. Let's see, 4, 2. 4 in for x, 2 in for y. 4 plus 2 times 2. Or 4 plus 4. Oh, wait a minute, that doesn't equal 11.
Nothing for you.
That one doesn't fit. Not all of them fit. Okay, some do, some don't. Negative 1, 6. Does that bad boy fit? Can you even use negatives? Oh, sure you can. It's going to be a point, as you saw earlier. Put a negative 1 in for x, and this 6 in for y. Let's see, negative 1 plus 2 times 6, or 12. Son of a gun. Negative 1 plus 12 does equal 11. So that one fits in. We've got a whole bunch that fit in. Now, wait a minute. Didn't we just do that one? Oh, no, 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 no. Order counts. Negative 1, 6 is different than 6, negative 1, isn't it? Well, that one fits. Let's see if the other one fits.
Oh, right, guys.
Well, order counts. 6 plus 2 times negative 1. 6 plus no way. That one doesn't fit. So, obviously, order really counts here. Okay, so some fit and some don't.
Do that again.
Let's do it with one other equation. This one's going to be a little easier. You'll see why later. Let's see, y equals negative 3 plus 2x. Some will fit, and some won't. Judge, does this one fit? 4 in for x and 5 in for y. Note I put the 5 in for y. Let's see. Negative 3 plus 2 times 4, or negative 3 plus 8. Son of a gun, it fits. Oh, can you use 0? How about that bad boy? Put a 0 in for x and a 2 in for y. Negative 3 plus 0, oh no.
Nothing for you.
That one doesn't fit. Now, 0 wasn't the reason it didn't fit. It just didn't fit. How about this bad boy? Put a 1 in for x and a negative 1 for y. Let's see. Negative 3 plus 2? That one fits. Some fit and some don't. 1.5. Son of a gun. You can, yes, you can use decimals. Okay, and 0 doesn't screw anything up all the time. Let's put a 1.5 in for x and a 0 in for y. 2 times 1.5 is 3. And 3 plus negative 3, son of a gun. It does fit. Cool. How about 2, 3? 2 in for x and 3 in for y. 2 times 2, 4 plus negative 3. Negative 3 plus 4, that one doesn't work.
You're despicable.
So we get the idea of ordered pairs fitting and not fitting into two variable equations, okay? Now I'm just throwing pairs at you. How about you coming up with the pairs, okay? Because that's going to be needed later on in this show, okay? Let's do some where you come up with the pairs. Well, let's see. Oh, got another one.
I can do that, but I don't want to.
Well, let's see. Find the missing coordinate. Well, in the first point, we're supposed to put 2 in for x, and we're supposed to find out what y is. Okay, I'll put a 2 in for x. Now I'll solve for y. I'll get rid of everything but the y. Get y by itself. 4 times 2 is 8. Now who's keeping the y from being by itself? The 8 and the 2. Let's subtract 8 from both sides and divide by 2 both sides. And in this case, if y is 4, it will work.
Oakley-do.
So there's we've just made a point fit in. 2, 4 fits in. The ones that fit are going to be the most useful.
Thank you, sir. I have another.
Okay, how about this one? How's that different from the first point? Well, in this point, we're asking you to put the 2 in for y. How do I know that? Because it's the second number, isn't it? Put it in for y and find out what the x is. Okay, let's see. And put it in for y. Multiplied. Now I got to get x by itself so that I know what it is. Let's perhaps subtract a 4 from both sides. I'm getting close to getting x by itself. I got to get rid of that other 4. He's multiplying, so I'll divide both sides, Buford. And in this case, x is 3. So that point, 3, 2, definitely fits in. You just made it fit in. Okay, let's find another one. If we put a 5 in for x, what would y be? Well, let's see. 4 times 5, put it in for x, and get 20, plus 2 times y is 16. Let's get that y by itself. Subtract 20 from both sides. Divide by 2 to both sides, and y is negative 2 in that case. It could happen.
Excellent.
So the point 5, negative 2 fits in. Okay, let's find one more. Now, in the next one,
Holy heart failure!
they're asking you to put in 0. Hey, 0's a number. You can win the lottery on 0. They're asking you to put 0 in for y, because it's the second number, right? I love putting in 0. It's easy, because it cancels everything out. 2 times 0, nothing, okay? I could just not write it even. Oh, yeah. Now all I have to do is divide by 4. Notice how I love putting in 0. And in that case, x is 4. Okay, so I found 4 points that fit into this equation.
Prepare to be astonished.
Now, why would I do that? Well, guess what? If I take the points that fit in to an equation, for instance, the point 1, 5, and I draw it on a rectangular coordinate system. Let's see, graph 1, 5. Go over 1 and up 5. Okay? And I graph 5, 3. That one fits in. Go over 5 and up 3. and negative 1, 6, go back 1 and up 6. Guess what happens? They line up.
Cool.
Is that cool as a mule? Well, you know what? There's way more than that line up.
Great horny toadies.
Yep, and they all line up and they go on forever. Okay? Now, something important you need to know about points, okay? You know how with your Aunt Minnie, you say that she's so wide that she uses 2 zip codes? Well, that can't work with points, okay? Because a point can't have any width if you think about it, okay? Because if it had any width, remember a point is mapping an ordered pair, okay? If it was over a teeny bit on the right side, it would be mapping a different number than the left side, okay? So it can't have a left side and a right side. It can't have any width at all. Now that's hard for you to imagine, I understand, okay? So what we do is we just think of points as being so small, okay? Of course, you think, well, it has to be something, it has to have some size. Well, really, they have no size, okay? They have no width and no height, okay? But instead of trying to imagine that, let's just make these points, take a look, just get smaller and smaller and smaller. Let's take a look. The ones that line up, now they're going to get smaller, and in fact, they're going to get so small, because I told you they're teeny, that guess what they're going to form?
It is alive.
It forms a line. All the points, infinite many, mind you, all the points that fit into this equation form a line. I think that's cool as a mule. Okay? In fact, these equations are called, get out of town, linear equations, linear equations. Cool. Okay? Now, most of your chapter here, they're going to be asking you to find that line or to draw a picture. You're really drawing a picture of this equation. Okay? Well, consider something. When we graph linear equations, okay, that's what you're doing. You're graphing, you're drawing a picture of the equation. Linear.
Do that again.
Better be a line. What's going to happen is you're going to find points that fit. Okay, that's why we were doing it before. Graph this point, 4, 5. 1, negative 1. 1.5, 0. I'm going to go over 1.5. I know you're a little nervous about this one. Go over 1.5 and up none. Okay, son of a gun, that is over 1.5 and up none. And over 2 and up 1. They, of course, line up. But do you need all 4? You know what's pretty cool? They line up. And they form that line. Now,
to infinity
that
and
line
beyond.
goes on forever. Okay, so there's many other points that fit in there. And,
now look at here.
In fact, do you need to find all the points? Okay? These points, and you're going to have to trust me, they all fit in, okay? I know they fit in because they line up, okay? If I was trying to find that line,
well, isn't that special?
I only need 2 of them. What if I just use these 2? I get the line. What if I just use these 2?
Well, doggy.
Same dad burn line. What if I use these 2?
Oh, gnarly!
I don't think you can screw this up. If you can get 2 points that fit in, you know where the line is, okay? Got to get those 2. Got to get at least 2, though, you understand? In fact, you're going to hear the term 2 points determine a line, right? As long as they're the right points, as long as they're the ones that fit in. Okay? Well, let's see.
Allow me to demonstrate.
We're going to graph this equation. It is a line. I know it's a line. It's got a y and an x there, okay? Well, I need to find some points that fit in. Okay?
Wait a minute.
There's an infinite amount, but how many do I need?
Phew.
I really only need 2. Now, I'm going to tell you to do 3, but we really only need 2.
Hello.
So I make a chart like this, okay? And I put in various numbers for x. I always put in 0. Remember how easy 0 is? Let's always put in 0. put it in instead of x. Well, let's see, instead of x, and it'll tell me what y is. 2 times 0, which is nothing, minus 1. So nothing minus 1, y is minus 1. Okay, there's a point. If I put in 0, I get minus 1 for y, so the point 0, minus 1. Let's plot that bad boy. Go over none and down 1. There it is. Okay, well, I need 2. So let's put in another. Let's think of the easiest number. There's your buddy, 1. Okay, remember you can put in anything you want. Okay, so don't make it hard on yourself. I put in a 1 for x. 2 times 1 is 2. 2 minus 1. Apparently y is 2 minus 1, or 1 in this case. So y is 1, and it happens that x is 1. Okay, let's graph that point. 1, 1. Go over 1 and up 1. Okay, now you already know where the line is, but you know what? I want to give you a hint. Let's do one more point. I'm not just trying to bother you. I want to give you a reason for doing one more point. Let's do it. We'll put in the next easiest point, 2. Okay, let's see. 2 times 2. I'm putting it in for x. Okay, 2 times 2 is what? 4. 4 minus 1. Y is 4 minus 1. So y is 3. Okay, let's graph the bad boy. 2, 3. Go over 2 and up 3. Now, I'm looking pretty good. Okay? You know why?
Yes!
They line up.
Wait a minute.
If they didn't line up, look what would happen.
Go!
If I do 3 points and they don't line up, I screwed up. Okay? That's why I always tell you to do 3. Always do 3. Even though you do, just make sure that you're right. Okay? And if they line up, you could be wrong, but chances are very good that you're right. Okay? So always do 3.
And you're going to do it because I said so.
Yeah. Okay? Get the idea? Because I want you to get 100 on these tests.
To infinity and beyond.
There we go.
And another thing.
Okay, let's try this one. This one's a little bit more difficult. At the beginning, anyway. We want to put in different numbers for x and get y's. Well, if we want to find y, then why don't we start off solving for y first? What's keeping y from being alone? The 2 and the 4x. Let's subtract 4x from both sides. Okay, that's gone. And 8 minus 4x, well, those are unlike terms. We can't do it. 8 minus 4x is just 8 minus 4x. Okay, now who else is keeping y from being alone? The 2. He's multiplying, so I'll divide. Of course, I have to do it to both sides. Now I get a cancellation here. And on the other side, I get y, y equals 8 divided by 2 is 4. And minus 4x divided by 2 is 2. Now you love this because now you've got a little recipe for y like we had in the first problem. Okay? This is going to be your first step for every equation that you want to graph. You're going to solve for y. Okay? Now later on in advanced algebra, when you get to that, there's going to be 10 other reasons that you want to solve for y. Okay? So get used to it. The first thing we're going to do when we're graphing a line is solve for y. Now we have our little recipe. Let's put in various numbers. Let's put in your buddy 0. He's easy. 4 minus 2 times 0, or 4 minus nothing. That's easy. 4. Okay, so we have a point. 0, 4. Go over none and up 4. There's your boy. Okay, now I need 2, but I'm going to ask you to do 3. So let's put in another point. Put in 1, nice and easy. Let's see, 1 for x. 4 minus 2 times 1. 2 times 1 is 2. So 4 minus 2 is 2. So in this case, using my y recipe, y is 2. And I have a point, 1, 2, one ordered pair. Go over 1 and up 2. Now I know you already know where the line is, but just to be sure, let's do one more point. Let's do an easy one.
What a maroon. What an ignorant.
Don't put in negative 87. I told you, put in an easy one, okay? Make it easy on yourself. It doesn't matter. You could put it in if you want. You could also slap yourself in the face, okay? Let's put in easy points, and we'll make less mistakes as well. Now you're talking, okay? Put in a 2. 2 times 2. 4 minus 2 times 2, or 4 minus 4 is 0. So in this case, 0. So over 2 and up none. Now you would bet the farm that you're right, okay? Now you're not done yet, though, because what do you have to do? I asked you to graph a line. Make sure that you draw the line. And remember, the line goes on forever.
To infinity and beyond.
Okay, so include those arrows at the end, too. This isn't graph a line segment. This is graph a line. Okay, so put those arrows at the end, because all the points that fit in are infinite. Okay?
Thank you, sir. I have another.
Okay, I gotta show you another one. Some craziness. What's the first step in these? You better remember. Do you remember? What's the first step? Come on, what's the first step? For Christ's sake, you've got to remember that. We're going to begin by solving for y. Now, who's keeping y from being by himself? That minus 2x, that's a pain, and that 3 next to the y. Let's start off adding a 2x to both sides. That'll get rid of the minus 2x. Okay, now let's see. 3 plus 2x, I can't do it, it's 3 plus 2x. Now divide everybody by 3. Now that's a little bit screwy. Dividing everybody by 3, that's going to cancel, and I'll get y is, well, 3 divided by 3 is 1, and 2x divided by 3, I don't know what it is, so I'll just write 2x divided by 3. Okay, this isn't going to be that bad. Relax, Francis. Now, what are we going to put in this time? Y equals 1 plus 2x over 3.
Now what am I going to do?
Not so bad. I promise. Remember, you can put in anything you want.
Hello. Hello. Hello.
Yeah, usually we put in 0, 1, and 2. But I got a hint for you. When there's a fraction, okay, it could make life way easier. Put in multiples of the denominator. I'll prove to you why that's going to make life easier. What's the denominator in this case? Let's see. 3. Okay, so I'm not putting in 0, 1, and 2 this time.
Pay attention, son. This is for your own good.
I'm going to use multiples of 3.
Oh, right, guys.
Okay, let's try it. I could have done 0, 3, and 6, but I'm going to do 0, 3, and negative 3. Okay? If I put in a 0, you love 0. You would marry 0. Okay, that's all gone. 2 times 0 plus 1, and that's an easy point. Let's graph over none and up 1. Okay, now watch this. You put in a 3. We've never put in a 3 before. Okay? Put in 3 instead of x. You love this, because look what happens to the 3's. Now it's not a fraction anymore. That's why I put that in. Okay, and 1 plus 2
You look marvelous.
is a 3. We got ourselves, that was easy, wasn't it? It looks scary, but it was easy. So over 3 and up 3. Okay, how about this negative 3? I don't like negatives. Don't worry about it. Cancel the 3's. And now the 3's cancel, but the negative doesn't. Okay, so we got 1 plus negative 2. What's 1 plus negative 2? Negative 1. So in this case, y is negative 1, and you can plot that point. Go back 3 and down 1. And you're looking good. Why?
Yeah, baby. Yeah.
Because they line up. Don't forget now, you have to draw the line.
To infinity and beyond.
And include the arrows. And you got yourself an example. Got yourself a linear equation.
Yoink.
Oh, how about this one? Now, I wouldn't give you a method that doesn't work all the time. You're going to have to learn to trust me, okay? So the same thing I've been telling you all along will work for this equation. Let's take a look. What do we start with? Okay, I'll remember that. Who's the troublemaker? The 3. Divide both sides by 3. In this case, y is 6 and 3. Y is 2. Okay, that's all right. Same deal. Now, there's no fraction here, so I'm just going to put in...
No!
What am I going to put in? There's no fraction. The 3 easiest numbers. 0, 1, and 2. Now, last time I put in multiples of the denominator because there was a fraction. There's no fraction here, so I just put these in. 0, 1, and 2. Now, sometimes it's so easy it's hard. If you put in a 0 for x, and there isn't an x, okay? So how easy do you want it? There isn't an x, and it's telling you, hey, bub, y is 2. Well, I get y is 2. If that's what they say, even in the next point. I don't care what x is. It says y is 2. Sometimes you just have to learn to take orders. The point 1, 2. Oh, this is looking good. What about the next one? I said y is 2. Sometimes it's really easy, over 2 and up 2. Now you know you're looking good.
You are correct, sir.
Because they line up, okay? Got to draw your line.
To infinity and beyond.
And you're hunky-dunky, okay? Now,
And now, ladies and gentlemen,
one more thing
for
I want to show you
our
today,
introduction.
not related to points because it's in the chapter, okay? And that's means, medians, and modes, okay? This is working with a list of numbers, okay?
That's the fact, Jack.
The mean of a list of data or numbers, also known as the average, is the sum of all the items divided by the number of items in the list, okay?
That's a fact, Jack.
That's what the mean is.
Well, doggy.
The median of an ordered list of data, of course, it has to be ordered, so you know what the median is, because the median is the middle number, okay? Of course, they have to be in order, or that'll change. Okay, now if there's 2 middle numbers, then it's the mean, or the average, of those 2 middle numbers.
Well, doggy.
That's the median. And one other word,
I have been chosen.
the mode. The mode of a list of data is the number that appears most often. The mode.
I have been chosen.
That's the idea of mode. Let's do one. Consider this ordered list.
Wait a minute.
Oh, wait a minute, it's not ordered. This only works for an ordered list, so if they don't give it to you ordered, you'll have to order it. I see 98 comes before 54. It's not in order.
Oh, yes.
Now we're talking. Okay, we got it all in order, okay, in numerical order. Now this will work. The mean, or the average, is going to be
Just a fact,
the
Jack.
sum of these divided by the number of items in the list. Well, let's see. The sum of them, okay, is 490, divided by how many there are in the list. Now, 7 in the list. So if we do this division, trust me,
Just a fact, Jack.
we get 70. Comes out nice. So the mean, or average, of these numbers is 70, okay? How about the median? We're looking at the list. Had to be, you see why it had to be ordered now, okay? Because it would have been arbitrary otherwise.
Well, doggy.
What's the middle number?
Hey, Wilma, I'm home.
There he is. So in this case,
Well, doggy.
the median of this list is 67. Now the mode
I have been chosen.
is the one that's chosen most often, is the one that appears most often. Well, let's take a look at this list. 54 appears twice. Nobody else appears twice.
I have been chosen.
So the mode is 54. Okay, that seems pretty easy. But,
on the thanks, Scarecrow.
okay, well, how about this ordered list? Well, let's go through the thing again. Have some. This is in order already, by the way, okay?
Wait a minute.
Yes, it is. Already in order. The mean
Just a fact,
is
Jack.
the sum of all the items divided by the number of items in the list. So let's sum these babies up. What do you get? Trust me, 87. And divide by, take 87, and divide by the number of items in the list, which is 10. Well, 87 divided by 10. We use our old decimal trick, moving the decimal over,
Just a fact,
and I get
Jack.
8.7. Remember that a mean or an average typically is a decimal. Okay, they don't all come out even. Okay, it's big leagues, man. Okay, so that's the mean. What about the median? Look at this list. Well, wait a minute. The median is the middle number, and in this case,
Hey, Wilma, I'm home.
I've got two middle numbers. What do I do when I have two middle numbers? Well, I take the mean of both of them, add them up. Okay, what's the mean of that? And then divide by 2.
Well, doggy.
So in this case, the average of the two, or the mean of the two, is 8.5. So the median of this list is 8.5. Get the idea? What about the mode? Uh-oh.
I have been chosen.
Who occurs the most often in this list? Well, I see 3 7s, but I also see 3 10s. Uh-oh. Well, I have two modes.
I have been chosen.
So it's the mode is, or are, 7 and 10. That's the deal, bub. Okay? That's all for today. Let's review what we covered. Okay, to graph ordered pairs. Remember how we do it. On the rectangular coordinate system, for instance, 3, 6, we start at the origin, that's the 0, 0 point, and do our x, then our y. In this case, we go over 3, then up 6. That's where the point is, okay? Now, it's very different. These are ordered pairs, very different than 6, 3, okay? You always do the x, then the y. In this case, we'll go over 6 and up 3. So order really counts, okay?
Allow me to demonstrate.
Remember graphing a line, okay? Now, this one's already solved for y.
Wait a minute.
Now, there's an infinite number of points. We only need 2. But I always told you to do 3.
Hello.
Let's do it. Put in 0. Always put in 0. He's easy. 2 times 0 minus 1, or 0 minus 1. In this case, y is -1. So to plot that point, we go over none and down 1. Okay, let's do another one. Put in your old buddy 1. Putting in a 1, 2 times 1, or 2. 2 minus 1 is 1. So in this case, y is 1. So is x. And to plot that point, we go over 1 and up 1. Now, you already know where the line is, but I always tell you to do 3 points. So let's put in 2. Make it easy on yourself. 2 times 2 is 4. 4 minus 1 is 3. We graph the point 2, 3, and we're looking good because they line up.
Yes!
Okay, now why do we always do 3? Because if we did 3,
Wait a minute.
Go!
and they didn't line up, we'd know we'd screwed up. So always do 3 points.
Nothing for you.
And if they don't line up, you know you screwed up. But if they do line up, you know you're okay. Always do 3.
And you're going to do it because I said so.
Okay, let's do one more example.
To infinity and beyond.
Thank you, sir. I have another.
Remember the ones where we had a fraction? For instance, how do we start this problem?
Hello.
Better remember. We got to solve for y. So let's subtract 4x from both sides. 8 minus 4x. Now we got to divide by 2. And y is 4 minus 2x. Now we can put in points. Okay, so remember to solve y. If I put in a 0, quickly I'll get a 4. Plot it. If I put in a 1, I'll get a 2. Plot it. And I always do 3.
What a maroon. What an ignoramus.
Put in easy numbers, please. Put in a 2. Remember that if it's a fraction, I put in multiples of the denominator, but I didn't have it in this case. And I get a 0. Plotting 2, 0. I am looking good.
Yes!
They line up.
To infinity
Don't
and
forget to draw the
beyond.
line, okay? Remember the ordered list thing.
Wait a
Has
minute.
to be an ordered list. Let's order these babies.
Oh, yes.
Now we're talking. Okay? Remember the 3 words you'll need to know. The mean, or average in this case,
That's the fact.
is the sum of the items divided by the number of items in the list. Add them up. Divide by the number of items in the list. In this case, 7.
That's the fact.
And you got yourself a mean. The median is a middle number.
Hey, Wilma, I'm home.
Now, if you have 2 middle numbers, you'll take the average of those 2. Okay, that's the idea of median.
Well, doggy.
67 in this case. And the mode
I have been chosen.
is the one that shows up most often. In this case, 54. Now, we could have 2 modes. Okay, if you have 2, you're not going to take the average of the 2. You're just going to list them both. Okay?
I have been
In
chosen.
this case, the answer is 54.
All on the fire, Scarecrow.
In this case,
Wait a minute.
the mean,
That's the fact. Yeah.
we have to add them up, divide by the total number,
That's the fact. Yeah.
and we have a mean of 8.7. This one,
Well, doggy.
we have a middle number,
Hey, Wilma,
and we have 2, so we'll take the average of those 2, dividing by 2, and we have a median of 8.5. In our mode,
I have been chosen.
we have 2 modes. It's a tie.
I have been
So
chosen.
we have 2. You get the idea.
Oh, I can't take it anymore.
Well, that's quite enough for today, I think. Okay? But you know what time it is now. That means it's time to do your homework. And don't make me come to your house, okay? Don't study your homework. Don't just look at it. Pick up the pencil and do it. Get the idea? Now, if you have any trouble, you can always go to the homepage. Remember it? At www.montgomerycollege.edu/pre-algebra, okay? Or you can email me at bwitty@mc.cc.md.us. Until next time, thanks for listening. Thank you. Oh, thank you very much.